Okay, let's give you guys some practice. So here's a graph of 1 over x. 1 over x. This is a graph of 1 over x. We're going to revolve it 360 along the x-axis. So you're going to get this surface here. Work out the area of this surface. I don't care about the area of the two ends. This one and this one. Just work out this surface area. Okay, and I'm expecting you to know these. So when you integrate this, it will give you this. We've done this before. When you differentiate this, it will give you this. So that means that whenever you see this, if you integrate it, it will give you the negative version of this. Okay, so well, I'm expecting you to know this. Work out the surface area. So press pause and have a go. Okay, so to do this, the surface area is given by this. So if you imagine cutting this up into many strips. This thing here is the arc length, and then you need to times it by the circumference of the circle, which is this thing here, 2 pi r. R here is really the height of our function, which is this thing here. So we can put this into the y. Well, we've done this before. The surface area is given by this. This is a constant, so we can take it out. So the surface area is given by this formula here. We need to work out dy by dx. So y equals 1 over x. So dy by dx is given by this. But then if you look at the formula, you need to square dy by dx. So when you square it, it will give you this. Because this thing squared will give you this. So now we can put this into here. That will then give us this thing here. Remember, this is a constant, so we can take it out. That will then give us this. And remember, the y value is 1 over x, so we can put 1 over x into here. That will then give us this. And we're integrating from 1 to 2. So that's from 1 to 2. So the surface area is given by this. So now merge these two together. That will then give us this, and then root a over b is the same as root a over root b. So that will then take us. So this thing here will then take us to here, and then this thing here is really x squared. It's really x squared. We can merge this with this, giving us x to the power of 3. Giving us x to the power of 3. And then, well, really the surface is given by this, but then this thing here, you can tidy up to give you this thing here. So now it comes down to us trying to integrate this. So to integrate this, we've got to use trigonometric substitution. So to integrate this, your eye should zoom into this bit here. Create a triangle in such a way that this thing here will be true. Well, if you make the opposite to be x squared, the adjacent to be 1, then the hypotenuse will have no choice but to be this thing squared plus this thing squared, and then square root the whole lot. So if you make this to be x squared and this to be 1, then the hypotenuse will have no choice but to be this thing here. So notice that this thing here is the same as this. So now we need to extract the dx from our diagram. So to extract the dx, we've got to consider tan. So tan the angle is opposite over adjacent, and then now obtain the differential. So differentiate this, that will then give us this. Differentiate this, that will then give us this. Divide both sides by 2x. So dx is given by this whole thing here. So later on we can put this into the dx. And then looking at this complicated thing, well, if you consider secant theta is given by hypotenuse over adjacent, by hypotenuse over adjacent. Well, secant theta is given by this. So we can now put this into here. We can put this into here. Leave the x to the power of 3 to later. So this whole thing here will then become this. will then become this. Okay, so now, notice that, hang on, notice that we are leaving x to the power 3, but then x to the power 3 can merge with this x here. So hang on. So we are currently here, and then this half here is a constant, so we can take it out here. So we cancel out this 2, leaving you with just pi. And then you've got x to the power 3 and x, that will give you x to the power 4. But then what is x to the power 4? Well, going back to our diagram, remember tan theta equals x squared. So if you square both sides, x to the power 4 is 10 squared. So going back to here, x to the power 4 is 10 squared. Okay, so we are currently at this stage here. I will continue in the next video. Okay.